about properties of logs yesterday, and we stopped here, right? I went through the properties, we just didn't actually do any examples, right?
Yes.
Okay, so let's talk about graphing this. Well, are you going to quit talking and pay attention to me at all? Yeah. Your white lie. I will quit talking to Ben in class.
No.
Okay. So, when we graph logs, we always change them to an exponential. So this is, f of x is the same thing as y. So if I wanted to change that to exponential form, what's the base of ln?
The e.
E. So in exponential form, what this means is e to the y power equals x. And so if you made a t-chart, when we graphed exponentials, I told you you always put in -1, 0, and 1, but we put those in for the exponent. So in this case, that is my y. So e to the -1 is 1 over e. E to the 0 is 1. E to the first is e. So we graphed e to the x yesterday. I told you e was like a 2.7-ish. So 1 over that would be a little less than 1/2. So we have 1 over e, comma, -1 for the first point. So 1 over e, 1, 0, and e, so like 2.71. And what happens is y could be any number, because you can put anything into the exponent. But x is what we get out, and you'll never do a number to a power and get 0 or a negative. So our graph ends up looking like this. So I told you yesterday the log is the inverse of the exponential. So what that means is the x and y just flip roles. So if we think about the exponentials all had a horizontal asymptote at 0, so logs all have a vertical asymptote at 0. Then the basic graph part looks the same. It's just a curve that we keep going here. So why don't you guys try graphing the second one? Change it to exponential, get your 3 points, draw your graph. You guys get it? What would the domain of that be? Zero to infinity. 0 would get a parenthesis because we don't ever actually hit it. What would be the range? All right. So I went to evaluate this using the laws of logarithms. Notice both of these are log base 2, and those logs are subtracted. Look at your notes from yesterday that we wrote down the laws of logarithms. When do you end up with 2 logs subtracted? When they were originally divided. So if we go backwards from here, we can condense these logs. We write the log base 2 once, and then we divide these arguments, 80 over 5. 80 over 5 is 16. So you might be able to look at this and know what log base 2 of 16 is. Anybody know? No.
I don't know.
Okay, so let's think about it. So if I set this equal to x, how would you write that in exponential form? 2 to the x power equals 16. Can you tell me 2 to what power equals 16? 4.
I was right.
You were.
Oh.
So logs give you an exponent, like saying 2 to what power is 16. So you might just be able to look at it, but you might have to actually write out your definition and go from there. Alright. So far, so good? Let's practice evaluating some logs. Natural log of x equals 5. What would we do? You write it in exponential form. So the base of the natural log is an e. And that's my answer. You could give me a decimal, but you could just say e to the fifth. It's not a pretty answer. And on test, you would kind of calculate it anyway, so this is all you can do. B. So what's the first thing? Change it to exponential. So natural log, that's a base of e. So e to the third equals x squared minus 1. Then what would you do? We're trying to solve for x. Add over the 1. And then you square root. When you add a square root, you need plus and minus. But remember with logs, the base is just like the base of an exponential, so it has to be positive. The argument is like what it's equal to. And if you take a number to a power, you always get a positive, right? So when we are dealing with logs, if I said like, if I did y equals log base a of x, both a and x have to be greater than 0. Y could be anything. Because in exponential form, can't you plug in any number you want for the exponent? But the base and the argument have to be positive. So, could this be a negative here for my x? No. You said no. Alright, C. 2 to the x minus 5 power equals 3. So does 2 to a power equal 3 that we know of? No, not a nice power anyway. So we have to think about another way to get there. These started out as logs, and then we changed them to exponential. This one is an exponential. So what we could do is add logs to each side. You can do the natural log or the common log, whatever you like. So in your equation, you have to do the same thing to both sides. Properties of logs. What happens to your exponent? Okay, if I'm trying to get x by itself, what would we do? divided by log 2 plus something. Yes, you could get decimals on all of these, but I'm okay with just leaving it like that. Is that okay? D. What would I need to do here? Add a natural log. You could do the regular log, but natural log, anytime the problem has e's in it, we like the natural log. Because what happens if you have a natural log and an e? They cancel each other out. Now, if you kept that natural log b, you're not wrong, it's just not totally simplified. So then I could subtract my 5. Divide by -3. And you could write that a couple different ways. You wanted to multiply everything by -1, do that. Either of these are equivalent. So, we are at the end of the chapter. You have the handout from yesterday to finish. I'm planning review day Monday, passed on Tuesday. So I'm also probably going to go ahead and give you your study guides today. You don't have to work on it, but we have a little bit of time left, so you might have some time to start it. So I'll go ahead and give that out. And then Monday would be a work and ask question day.